Hello everyone, welcome to Pepcoding. So in this video, we are going to discuss the question diagonal order sum of a binary tree. So we will be given a binary tree and we have to print the sum but in diagonal order. So let us move to our binary tree. So this is our binary tree and talking about diagonal order sum of a binary tree. So you must first visit a question which is diagonal order traversal in a binary tree. So this is a separate question. If you haven't watched the video of this question, then first go and watch the video of this question. Then you can easily understand and relate this question with this one. So what does diagonal order mean? So talking about from root, so this will be diagonal 0, this will be diagonal 1, this will be diagonal 2, and the nodes coming in the direction of diagonal 0 will belong to D0, and coming in the direction of D1 will belong to D1. These all nodes will belong to D2. So specifically D0 will contain 1, 3 and 7, and D1 will contain 2, 5, 6 and 13, and D2 will contain 4, 8. And in this question what we have to do, we have to find the sum. So this will contain 11, this will contain 26, this will contain 12. So overall we have to find the sum. Okay, so think about the solution approach. So what we'll do, we'll take help of a queue and we'll be storing our answer in an answer, and we'll be taking a variable sum in which we'll store the sum of these nodes. So how we're going to implement this? See, firstly what we'll do, we'll add the root value in our queue. Okay, and then we'll check its left child. We'll firstly the size is 1. So what we'll do, we'll try to remove the element from queue, and while removing, what we'll check whether it is having a left child. If it is having a left child, we'll add it into this, and we'll add this 1 into our sum. Initially it will be 0, and we'll add this into our sum while removing. We'll add this into sum, and we'll check if it is having any left child. If it is having any left child, then we'll add in q, and if it is having any right child, then we'll add in our sum. Okay, then again for 3 we'll check if it is having a left child, then we will add in our q, and we'll check whether it is having any right child. If 3 is having a right child, then we'll add into our sum. Again we'll check if 7 is having any left child. No, 7 is having no left child, so we'll not anything in our q, and we'll check if 7 is having any right child. So 7 is having any right child? No. So from here we have achieved a sum value. Okay, and we'll reduce the size of this q, and now the size of q will be 2. So we have achieved the sum value for our diagonal 0. How? 7, 3, 10 plus 1, 11. We'll store this sum in our D0. Okay, so again what we'll do, again we'll start from 2. We'll take a fresh variable, we'll again initialize sum with 0, and what we'll do, we'll check for 2 now. We'll check whether 2 is having any left child. If it is having any left child, then add it to the, firstly try to remove and add it to the sum, then check if it is having a left child and right child. If it is having left child, then add it to q, and if it is having right child, then add it to sum. Okay, now again we'll check for 5. If 5 is having any left child, no. 5 is having any right child, no. So from here what will happen, 5 is not having any right child, so we'll leave from here, and we'll check whether the size is still 0. No, size is 1. We'll come out of this sum when our size will be 0. So we are still having a node which is 6. So we'll remove 6 and we'll add 6 into this, and we'll check its left and right. Whether it is having any left child? No. So is it having any right child? Yes. So we will add in sum. Okay. So now again we'll check for left and right. We'll check for left and right. Is 13 having left child? No. Is 13 having right child? No. So again we'll decrement the size. So now it is 0. Now we'll come out of the sum, and the sum will be containing 26. Okay. So our D1 will contain 26. Now till here size is 1. Now for again this sum will become 0, and we will be checking for 4. We'll remove 4, add it into sum, check for its left child. Is it having any left child? No. So we will not add into Q. We'll check for right child. Is it having any right child? Yes. So we'll add in sum. Okay. So this will become 12. So again we'll check for 8, left and right. Is it having left child? No. Right child? No. Then we'll decrement size, and now we'll check this size is 0. So we have stored our sum. So this will contain 12. And now we'll check for size of Q. Now the Q is empty. So this all work we were doing till our Q size was greater than 0. So our outer loop will be having the condition while Q dot size is greater than 0. And as soon as Q dot size becomes 0, our answer will be returned. Okay. So now this thing we'll implement in our code. So let's move to our code section. So this is our function diagonal order sum. We'll be writing our code in this. So our very first step is to create a queue. We are implementing queue. So linked list of nodes So now what we'll add? We'll add root value in our queue. So we'll be implementing add last function because we are adding the elements in our last. Then what we'll do? We'll create a loop. Till what? Till Q dot size is greater than 0. Okay. Let me remind you that we were returning the answer when at last position our Q dot size was became 0. So that is why we'll be doing till Q dot size is greater than 0. So now also we will store size of Q, and we'll be creating one more loop while size minus minus greater than 0. Okay. Now we were removing the node. So Q dot remove. So we were removing from the first. So Q dot remove first. Okay. Now what we were supposed to do? We were checking its right again and again. And if we were getting the right, then we were adding into the sum. So that is why we till where we were doing this thing. till the node of right was null. So we were making the node equals to node of right. Then we will do this thing till our node not equals to null. So why? See, if you are not getting this thing, then no need to worry. I'll be comparing each line with our dry run. So while node not equals to null, then we'll be adding into sum. Okay, and we were also supposed to initialize sum again and again. So okay, if node of left not equals to null, then add it to the queue. Okay, so q dot add last node dot left. Node equals to node dot right. And after completing this while loop, we were storing this sum value in our answer. So let us create the answer first. So array list of integer so this is okay. Now what we'll do, we'll add so remove this. Okay, so now you can relate. After completing while loop, add this sum value into answer and then return answer. So let us do few steps of dry run. So that you can relate well. So I hope it is visible to you. So let me erase all these things. So what is the first step? We have created a queue and we will be adding this root value in our queue, and then we will checking while condition. If q dot size is greater than 0, yes, q dot size is greater than 0. Then we'll be also maintaining a sum. Sum is containing 0. So size minus minus, we'll be decrementing this size in post order. So 1 is greater than 0, yes. So now we'll remove this node, and what we'll do, after removing this node, we'll check while node not equals to null. Yes, node is not equals to null. Then add this value, add this node dot value in our sum, and then check if node dot left not equals to null. Check node dot left not equals to null. So node dot left is not equals to null. This is node dot left. So what we'll do, we'll add this in our queue. We'll add this node dot left in our queue, and then what, we'll make this node as node dot right. So now our node is pointing to node dot right. Okay, and what next? Then we'll again come into this loop while node not equals to null. So node is, see, we have added the sum node dot value in our sum, then call to node dot left, which was not equals to null. So we have added this thing. Now we have made this, we are denoting this node to node dot right. Then node is not equals to null, yes. Then what we'll do, we'll add this node dot value in our sum. We are adding this node dot value in our sum, and we'll make a call to its left to check whether its left is not equals to null. Yes, its left is not equals to null. Then add it to the queue. So we have added this into queue. Now we'll make this node as node dot right. So again it is pointing to node dot right. Now again we'll check while node not equals to null. Yes, node is pointing to 7. It is not equals to null. Okay, right now node is pointing to 7. It is not equals to null. So we will add this in our sum, and we'll call and we'll check whether its left is not equals to null. So its left is not equals to null. No, its left is equals to null. So we'll not go into this if condition. We'll make this node as node dot right. So node dot right is pointing to now null. Now node is pointing to null. So is node not equals to null, which is false. So we will come out of this while loop, and what we'll do, we'll go to this while loop. Here size has become 0. So 0 is greater than 0, condition false. So this condition is also false. Now next what we'll do, we'll, after terminating from this while loop, we'll add this sum to our answer. So our sum value was 11. So we'll add this answer, this sum into our answer, and again we'll come to this q dot size. So now q dot size is 2. So what we'll do, we'll come into this size is 2. Okay, now we'll remove this, and we will check whether node not equals to null. Yes, node not equals to null. Then what we'll do, we'll add this into our sum. Now the sum has initialized to 0. So it is right now this. So sum will, node dot value will get to sum. Now we'll check if node dot left not equals to null. Yes, it is not equals to null. So we'll add this into queue, and then we'll make this, we'll make node equals to node dot right. So we'll make this node dot right. So now node is pointing to 5. Okay, node dot right. Initially it was pointing to 2. Now it is pointing to node dot right. Now again we'll come into this condition. Is node not equals to null? Yes, node not equals to null. Then what we'll do, we will add this value. We'll add this value into our sum, and then we'll check if node dot left not equals to null. Is it null? Yes, it is null. So we will make this node dot right. Now node dot right is pointing to null. Okay, so what we have to do now, if it is pointing to null, then we will come into this while loop. This condition will become false. We'll come into this while loop. Now the size is 1. Now the size is 1. Again we'll come inside this while loop. We'll check node. We'll remove this node, and we'll check if node not equals to null. Then add this into our sum. So we have added this into our sum, and we'll check if node dot left not equals to null. So it is not equals to null. 6 dot left not equals to null. No, it is equals to null. So we'll not come into this if condition. We'll make this node equals to node dot right. Right now node is pointing to 6, and node dot right will be 13. So now it is pointing to 13. Okay, now again we'll come into this while loop. Is node not equals to null? Yes, node not equals to null. then sum will have node dot value, which is 13. And node dot left not equals to null. No, it is equals to null. So we'll add nothing to RQ, and then we'll make this node equals to node dot right. So our node will become null now. So now again it is node equals to null. So we'll come out of this loop, and now size has also become 0. So we will add this sum into our answer. So this sum will be 26. We'll add this 26 into our answer. So this is how our code will work. So now let us submit it. So there is some error. Okay, so this will be 19 line. Array list of integer. We haven't given the name. Answer 32 line number. Okay. Answer dot add sum. Okay, accepted, submitted. Okay, so everything is working fine. So I hope you have understood this question. So we'll be meeting in another video with another question. So thank you for watching.